Okay, Shaima. Okay, no problem. C class, what's the answer coming? See, it's a triangle that is given and the PV diagram has been mentioned for a cyclic process ABC drawn in order. Coordinates A, B, C, these are mentioned 4, 1, 2, 4 and 2, 1. This basically whenever coordinates are mentioned, that tells you the distances from X and Y axis. Okay. Now you have to calculate the work done. Which process is this? What do we call such process? Cyclic. Class, it is completely ending. So what do we have when we have to calculate the area? Look, this will also be included as the trapezium. So this will completely be formed as the trapezium. So what will be the area of the trapezium? Area of trapezium is half the sum of parallel sides plus the height, right? So here what all we'll have, see, this is 4 minus 1 for the height, right? And this is in liter also. So we have to convert it into meter cube also. So this will be 4 minus 1. This will be 3 into 10 to the power minus 3. Right. Now, for the next one, this separation, this is 4 minus 2. Right. So that will be 2 into, that will be 2 because this is the force, right? This is already, sorry, not the force, the pressure. So into 2. Now, again, what do we have? We have simply the rectangle. This is half into base, half into height into base plus now this rectangle. This is first portion done. This is second portion. Or what you can, we can directly do this also as taking this as the trapezium. Half into the sum of parallel sides into the height, right? So that can also be done, or this can also be done, that you can take this as the second figure plus the first figure. So when you're considering the rectangle that is present, it will be 3 into 2, right? But when we're talking about 3, it will be 3 into 10 to the power minus 3 into 2. So when you will solve this, this will be 9 into 10 to the power minus 3. Okay, so this is which part? This is A to B. A to B has totally been covered. Now coming to the next part. A to be done. Now B to C. Now, when we are just having B to C, what we have to take? See, 3 into 10 to the power minus 3 into 2 part, the last part only. 3 into 10 to the power minus 3 into the last part only. But there's a catch in this. It won't be just this much of joules. This is also joules. The work done won't be this much. Why? Can anyone tell? Is there any error in this? See, this is the figure. Can anyone tell any error in this? Class, this arrow, it will be negative. It's compression now, so this will be negative. Now the last part, when work is being done from C to A. Look, can you notice from C is this point. This is C to A point. So here the volume is constant. So when the volume is constant, the work done will be what? 0. So when you are adding all of it, see, this is 9 into 10 to the power minus 3. This is minus 6 into 10 to the power minus 3. So when you are calculating the total work done, see, it will be work done from A to B plus work done from B to C plus work done back from C to A. So this will be 9 into 10 to the power minus 3 plus minus 6 into 10 to the power minus 3 plus 0. So this will be 3 into 10 to the power minus 3 joules. Write this quickly. We'll see some more questions. See, what does this question say? It says 1 meter cube of water is converted into 1671 meter cube of steam at the atmospheric pressure and 100 degrees Celsius temperature. Now, latent heat of vaporization of water is given. LV is given 2.3 into 10 to the power 6 joules per kg. And 2 kgs of water can be converted into steam. So water getting converted. See, you have to be very careful. Is the temperature changing or the state of matter changing? Now, how much will be the increase in its internal energy? So as soon as internal energy comes, first law of thermodynamics should be there in your mind. So see, heat gained by 2 kg of water. So heat gained by 2 kg of water. What will it be? Q is equal to ml, right? Because water state is changing, right? So mass is 2 kg and this is 2.3 into 10 to the power 6. So 2.2 into 2.3 into 10 to the power 6. So this will be 4.6 into 10 to the power 6 joules. So this is the heat gained by 2 kg of water. Now volume of 2 kg of water. Volume is mass by density. Density is equal to mass by volume. So volume will be mass by density. So that will be 2 divided by 10 to the power 3. See, this is the density. So this will be 2 into 10 to the power minus 3 meter cube. So this is the volume. Why do we need the volume? This is saying the volume of the steam formed by 1 meter cube is already given. The volume of steam formed by 1 meter cube. It was given 1671. This is already given in the question. How much it was? Yeah, 1671, 1671 meter cube. So now what if 1 meter cube is forming 1671 meter cube? So how much? 2 into 10 to the power minus 3 will be forming. So we'll multiply. 2 into 10 to the power minus 3 will be forming 2 into 10 to the power minus 3 into 1671. For unit, you know, right? For the unit value, you already know this. So for the bigger one, you can multiply. So this will be 3342 into 10 to the power minus 3 meter cube. What is this? This is the volume. Now what should we do with this volume? Firstly, if 2 kg of it, let's say this is the total volume we have got 3342. From this, some amount has evaporated. 2 kg has been converted into steam. So what amount is left right now? What is this part? This part which is left. So what you can do? You can simply subtract the value that you're getting. 3342 into 10 to the power minus 3. Subtracted from 2 into 10 to the power minus 3. So this will be 3340 into 10 to the power minus 3. What is this? What have we got? This is the increase in volume, right? This is the increase in volume. Change in the volume or increase in the volume when water changes into steam. When 2 kg of water changes to steam. So if you have change in volume, can't we calculate the work done? if we have the volumes change, dV we have, so we can apply this concept that work done will be PdV. Atmospheric pressure we'll take, that is 10 to the power 5 multiplied to this whole thing 3340 into 10 to the power minus 3. So this will become 3340 into 10 to the power 2, right? Or let's directly write this as 0.334 into 10 to the power 6 joules, the work done. Why did I do this step? See, because your latent heat was also given in 10 to the power minus 6. Right. Now, what's the heat? Here, what's the heat? We calculated the heat in here. 4.6 into 10 to the power minus 6. Can you just recall now? Work done is there. Heat is there. What is the question asking? To calculate internal energy. Can we calculate the internal energy now? See, that's why I converted this is into in 10 to the power 6. So that's why I wrote it in 10 to the power 6. So first law of thermodynamics. The change in internal energy will be heat minus the work done. This is 4.6 into 10 to the power 6 minus 0.334 into 10 to the power minus 6, which will be 4.263 into 10 to the power 6 joules. This is the internal energy. Okay. Write it. Write down the solution, all of you. See class, this says an ideal gas has a specific heat constant pressure, that is Cp is given as 5/2 times R. The gas is kept in a closed vessel of volume 0.0083 meter cube at a temperature of 300 Kelvin and a pressure 1.6 into 10 to the power 6 Newton per meter square. Amount of heat energy supplied to the gas is 2.49 into 10 to the power 4. You have to calculate the final temperature and the pressure of the gas. Okay, the pressure also you have to calculate and the temperature also. So see, pressure we'll calculate it in the last. First, let us find out the final temperature. What's the initial pressure given? 1.6 into 10 to the power 6. This is the initial pressure that we have. Now we are going to use the ideal equation. PV is equal to nRT. And from here, first let us calculate what are the number of moles, because number of moles are not mentioned in the question. P, V, R, and T, they all are there. We can get the number of moles. So number of moles will be PV by RT. Okay, PV by RT. So pressure is 1.6 into 10 to the power 6. Volume is 0.0083 divided by R. We will take it as 8.3 only, and temperature is given as 300 Kelvin. So once you will solve, you will get this value as 16/3. Now, Cp we have 5/2 R. We don't have the value of Cv. So what we'll do, we'll calculate. See, I hope you know Cp is plus Cv is equal to R. So for Cv, we can calculate Cp minus R. That is 5/2 R minus R, which will simply be 3R/2. So now we have Cp, we have Cv. But why did I calculate Cv? Because if you remember Nc delta T, Ncv delta T. See, 2.49 into 10 to the power 10 to the power 4 joules of heat energy is supplied. So suppose, let's say its temperature, let's say temperature is increased by delta T. Okay, so your Nc delta T, molar concept, if you remember, molar specific heat capacity, it was Nc delta T. We can at least equate it with the total heat. This will be the formula for heat. Now, number of moles are also present. Delta T, we'll be able to calculate delta T from here. This is 16/3. This is 3R/2 into delta T. This is 2.49 into 10 to the power 4 into 10 to the power 4. So when you solve this, so this will come around 375 Kelvin. Okay. The change in the temperature will come around 375. So the issue is that this is not the final temperature. What is this? This is the change in temperature. This is the change in temperature. So for the final temperature, what we can do? We have 300. You can add this. See, T plus 375 only will give you. So that is 300 plus 375. That is 675 Kelvin. So we have the new temperature. T prime will be 675 Kelvin. Now, initial temperature was 300 Kelvin. Final temperature is 675 Kelvin. Initial pressure is 1.6 into 10 to the power 4 Newton per meter square. Sorry, 6, na? It was 6. Now P dash. So you know pressure and temperature, they are directly proportional. P dash by P will be T dash by T. We need this. So P dash will be P multiplied to T dash by T. So P dash will be 1.6 into 10 to the power 6 into 675 divided by 300. So this will be 3.6 into 10 to the power 6 Newton per meter square. So this will be the pressure. Okay, so it's a good question. These kinds of questions can come in your exam. This is a very good question. It involves lots of concepts from the specific heat capacities. Please write this down. I hope you have written the question. I'm scrolling directly to the answer. Somebody has not written the question, please text. Okay, coming to this question, this says the compression ratio of certain diesel engine is 15. This means that air in the cylinder is compressed to 1 by 15th of its initial volume. Means V1 by V2 is given as 15, right? Then it is saying if the initial pressure P1 is given as 1.0 into 10 to the power 5 pascals. And the initial temperature T1 is given as 300 Kelvin. You have to calculate the final pressure. This is missing. And temperature after compression, gamma is given as 1.4. Gamma is used for the adiabatic processes. So P2, and basically you have to calculate this P2 and you have to calculate this T2. P2 and T2. Okay. Now, for the adiabatic process, when we're talking about the pressure and volume, you know it is P1 V1 to the power gamma equal to P2 V2 to the power gamma. So let's put in the value. This is 10 to the power 5 into. Okay, we don't have the individual values of V1 and V2. So what can we do? We can write P2. See, P1 is there. V1 by V2 to the power gamma can be equal to P2. So that is 10 to the power 5 into, this is 15 to the power 1.4. This much of pascals, right? So this you can solve. I'll tell you the answer. Answer is 44.3 into 10 to the power 5 pascals. This is the answer for P2. The new pressure. Now coming to the temperature. Temperature we are going to use T1 V1 to the power gamma minus 1, right? Similarly, T2 V2 to the power gamma minus 1. Now, again, we need to calculate T2. So this will be T1 into V1 by V2 to the power gamma minus 1 is T2. So what is T1? That is 300 into what is V1 by V2? 15. 1.4 minus 1, that is 0.4. So when you will solve, this T2 will come as 886 Kelvin. Usually the powers will be better than this in your exam, where you just have to put in the values of gamma like cube and square and all, okay? Write this.